The standardized normal. Any normal distribution with any mean and any variance combination can be transformed into a standardized normal distribution, Z, with mean 0 and variance 1. A normal distribution, okay? A normal distribution has mean mu and variance sigma square. Mu and sigma square can take any value that can be changed or that can be transformed into a standard normal distribution or a standardized normal distribution. And instead of calling it an X for explaining a normal distribution, for expressing normal distributions, we were using the alphabet capital X. In order to express a standardized normal distribution, we use the letter Z, the capital letter, with a mean of 0 and variance of 1. A standard normal distribution's mean or mu is always 0 and its variance is always equals to 1. Hence, a standard normal distribution is expressed like this. Z is normally distributed with a mean of 0 and a variance of 1. We know this is how we are always supposed to express a normal distribution. Once we have standardized our normal distribution, this is how we express it. A standardized normal distribution always has a mean of 0 and a variance of 1. This is how the diagram looks like. This is how the probability density function of a standardized normal distribution looks like. Okay? The mean, as I already told you, is 0. That means the median and mode is also 0. And the spread, that means this distance between the mean, the center, okay, the distance from the center to one point of your probability density function, this spread is equals to 1. We have to transform our X units, that means our normal distribution's X units, into Z units. That means we have to transform our X's into Z's, our normal distributions into standardized normal distributions, by subtracting the mean of X and dividing it by its standard deviation. Okay, so in order to transform a normal distribution to a standard normal distribution, we subtract the mean from X and divide that difference by sigma or standard deviation. Let's now look at an example. If X is distributed normally with a mean of 100 and standard deviation of 50, the Z value for X is 200. So X is given, which is 200. The mean and standard deviation of the normal distribution is also given, which is 150 respectively. All you have to do is find the Z value. For X, we have to convert the X to Z. You know that standardizing, okay, a normal distribution to a standard normal distribution requires you to do this. Z is equals to X minus mu divided by sigma. X is 200 minus mean is 100 divided by 50, and your Z becomes 2. So we have now standardized your X to Z. X was 200, which has now been standardized to 2. See, standardization is very simple and it is also very, very useful. Let's now compare the probability density functions of X and Z. That means a normal distribution and a standard normal distribution. Look at the diagram. Nothing has changed. For the normal distribution, mean was 100. The outcome X was 200. Now that we have standardized it, you know a standardized normal distribution has a mean of 0. And now the X has been transformed from 200 to 2. The distribution is the same, only the scale has changed. The scale has become much smaller now. We were talking in terms of hundreds, now we are talking in single digits. We can express the problem in original units, that means in the form of X, or in standardized units, that means in the form of Z. Expressing it in the form of a standardized unit is easier expressing such problems, expressing such experiments. These are much easier in everyday problems. Hence, we will use standard normal distribution for the rest of this chapter. That's what we will focus on. Now we know that probability, which is the area under the curve, is always equals to 1. The total area under the curve is 1, which basically means your total probability is equals to 1. We know that the curve is symmetric. That means the right hand side of the curve is a mirror image of the left hand side of the curve, and vice versa. So if your mean lies right in the middle, in the center, if your mean is right in the middle, if mu lies over here, this divides your normal distribution probability density function into exactly 2 halves. So this is 50% of all the probabilities, and this side is the remaining 50% of all the probabilities. So if the total area under this curve for a range of -infinity to a +infinity, if the total area is equals to 1, or if the total probability is equals to 1, that means on the left hand side, okay, from -infinity till the mean in this part, your total probability is equals to 0.5. And on the right hand side, starting from the mean to +infinity, are the remaining 50% of your probabilities. That means there's the remaining 0.5 of your total probability. So 0.5 probability lies over here, and a total of 0.5 probability lies over here. The two sides together makes up your total probability of 1. Alright, so the total probability in the left half is 0.5, the total probability in the right half is equals to 0.5, and hence that brings us to our total of 1. Appendix table number 1. The standardized normal table, or the Z distribution table in the textbook, shows values of the cumulative normal distribution function. Okay, so if you go to the very end of your book, the 8th edition, it has I hope all of you already have it. On the very end of the book, in the appendix section, you will find table number 1. Table number 1 is your cumulative normal distributions table, okay, where you will find all the probabilities listed. For a given Z value, the table shows FA, that means area under the curve from negative to A. So if there's a point on your standard normal distribution's probability density, if A is an outcome, the table will give you the value of FA. That means it will give you the probability of Z for all the values starting from a -infinity till A. Okay, you do not have to calculate the probability. The cumulative probability is given in the table. All you have to do is find it. You have to learn to identify the probabilities from the table. So before you start watching the next lecture, before next week's lecture, I want you all to have table number 1, that is the standardized normal table, in front of you, ready in front of you, because I will teach you how to read it, and it is very, very, very important. Thank you.